In this video, we're going to look at rotating a shape. When we're rotating a shape, we need to consider three things. The first one is going to be the center of rotation. So if we just jot this down, it's the center of rotation. An example might be the origin, or 0, 0. We might have 1, 2, or 5, 4. So we're looking at a center of rotation. The second one is the angle of rotation. Generally speaking, we will have multiples of 90 degrees. So 90, 180, 270, 360, and so on. So we've got an angle of rotation. Finally, we have a direction of rotation. The direction is either clockwise or anti-clockwise. So direction of rotation. So let's go ahead and look at some examples of each. So the center might be 2, 1. So x is 2, y is 1. It might be 0, -3. So the x coordinate would be 0, the y coordinate would be -3. The angle of rotation might be 90 degrees. It might be 180 degrees. It might be 270 degrees. 180 degrees anti-clockwise is the same as 180 degrees clockwise. So anti-clockwise and clockwise are the same. So we've got anti-clockwise, and if we go anti-clockwise, it will be this way round. So that is anti. If we go clockwise, it will be the other way round, like so, and that will be C. So let's go ahead and look at a shape, and we're going to perform some rotations on the shape. So here we've got a small right angle triangle. Its vertices are at 2, 2, 4, 2, and 4, 4. This dot here is the center of rotation. So at the moment it's 1, 2. If I put it here, it's 1, 1. We've got 2, 1, 3, 1, and so on and so forth. I'm going to put it back just here. What I'm going to do is rotate this shape. The center of rotation is going to be 2, 1. And I'm going to rotate it clockwise by 90 degrees. If I do that, the shape will come round like so, and I'm going to stop it just there. So if I do that, we've got now a shape. The triangle has been rotated about the point 21 clockwise by 90 degrees. We can see that these two lines are parallel and these ones are. So if this was labelled up shape A, this could be shape B. This is 1/4 of a turn. I'm now going to rotate it 180 degrees about that point, and this is half a turn, and that will end up just here. So again, we've got these lines being parallel, and we've got a 180 degree rotation about the point 21, and it's either clockwise or anti-clockwise. So if we think about this, 90 degrees clockwise is the same as 270 degrees anti-clockwise. If we have 90 degrees anti-clockwise, it's the same as 270 degrees clockwise. So if I just put that back where it was, that is the original shape, just there. I might want to change the center of rotation. We're now at the point 1, 0. So x is 1, y is 0. This time I'm going to rotate it 90 degrees anti-clockwise about that point, and it will end up just there. Again, we can see this is parallel with this one, and this one with this one. If I went to 180 degrees, or half a turn, we would be just here. So going half a turn clockwise is the same as half a turn anti-clockwise, and we can see that by simply spinning it round the other way. So that will look something like so. So let's go ahead and put that back. This is quite hard to show on the computer how to actually do it when you're in an exam, but we'll have a go at it anyway. So what I'm going to do now is look at a shape on the grid. I've got a center of rotation at 2, 1, and what we're going to do is look at rotating this shape. The way to do it is get tracing paper and draw over the shape. So what I'm going to do is pretend here if I put a piece of tracing paper on it, and what I'm going to do is just quickly draw the shape on here. You might want to do it with a ruler, it's entirely up to you, and that's what I'm going to have. I'm going to put an arrow pointing upwards, And with my pen on the tracing paper, I'm going to place it on this center of rotation. All I'm going to do is move the tracing paper around. So if I wanted, for example, to do 90 degrees and we were going to go clockwise about the point 21, so these are the three pieces of information. I've got now an angle, I've got a direction, and I've got a point. What we would do is turn the paper until the arrow points to the right, east, or 3 o'clock if you like on a clock. So that would bring us to here, 90 degrees clockwise, by simply putting the point of our pencil here and moving the paper around until the arrow points in this direction. If we did 180 degrees, remember this is either clockwise or anti-clockwise, about the same point, pencil on here after we've drawn over the top, and we would turn it until the arrow is pointing down. And that would give us 180 degrees, either clockwise or anti-clockwise, about this point. If we wanted to now do 270 degrees, and that's going to be 270 degrees clockwise, about the point 21, as we've got it just here, all we would do is wait till the arrow is pointing to the left, or if you like west, or 9 o'clock on the clock. That's 3/4 of a turn. So 90 degrees is 1/4 of a turn, 180 degrees is half a turn, and the 270 is 3/4 of a turn clockwise, or 1/4 of a turn anti-clockwise. We would simply redraw the shape. So all I do is wait till it gets in that position, look at where my shape is, and redraw it on the paper. So we can replicate this one just here. Let's put it here. So that's the same center of rotation, just here, 2, 1. And I'm now going to rotate the shape 90 degrees clockwise, which was the first one we looked at, and we would simply redraw the shape just here. So on mine, I would go ahead now and I would draw it, and it would be just here, and we would draw it like so. That is an example of 90 degrees. Let's go ahead and look at 180, and that would move it down to here. So if we were asked to do that, we would redraw the shape as shape B down here like so. And that we can see would look something like that. If I wanted to do 270 degrees, I would simply now go 90 degrees anti-clockwise, and that would give me the shape here. So that would be this one. But what we would see on the piece of paper is that the arrow would be pointing to the right for 90 degrees, down for 180 degrees, and to the left for 270 degrees. So that is carrying out a rotation. Center of rotation, direction of rotation, and the angle of rotation. What we're now going to do is look at describing a transformation. So what we might be given is a question, and it might say describe fully. So let's just jot this down. Describe fully a single transformation, and I'll just jot this, single transformation, that maps A to B, that maps shape A, This will be worded better, A to B, in the exam. So let's look now at transformations. The first type we have are translations. That simply means that we're going to move the shape. If we have a reflection, we could have now a reflection in a given line. We could have an enlargement. So an enlargement is going to alter the shape by either making it bigger or smaller. And finally, we can have a rotation. With your rotations and reflections, some of them you could use different examples. You just asked to describe fully. So for example, if you can find a rotation that's also a reflection, or a reflection that's also a different particular one, then that's perfectly fine. So for example, now reflection might be a translation, but in this particular example we're going to look at using a rotation. So what I'm going to do is look at this now, and we would be given this on a piece of paper, and we would say describe fully a single transformation that maps shape A to shape B. We can see that it isn't an enlargement, it isn't a translation, So what we're going to do is look at this being a rotation. There are a few different approaches that you could use for this. One of them is to take a piece of tracing paper and simply draw this shape on, find a center of rotation by trial and error, and wait until the shape fits. An alternative approach with this particular one is to simply take the vertices of the triangle and consider now what's happened to the shape. So what I'm looking at here is a rotation, and I'm thinking to myself, this point is going to come over here. We're now going to look at the other vertices of the triangle. So if we look at that now, what we're going to end up with, that point is going to go there. This one is going to go to just here, so let's put that just there. And then finally, this one is going to come down to here, which will look something like that. So let's just go ahead and check that looks good. That looks pretty good. We now consider the point that those three lines intersect, and we can see now that this is just here. So we have now x is -1, y is 0. So we need to state fully a single transformation that maps shape A to B. So I'm going to write down that it's a rotation, so we need to state the type. We're going to state that it has now an angle of rotation, and that is going to be 180 degrees, and we can just put that it either be clockwise or anti-clockwise. I'd write the whole words here, clockwise or anti-clockwise, as we've seen. We're interested in the center of rotation, and we can see now the center, or if you want to write about, we've got -1, 0. So that now is describing fully the single transformation that maps shape A to shape B. It's a rotation, 180 degrees, either clockwise or anti-clockwise, and the center of rotation, which we found just here, is going to be -1, 0. As stated, what you can do is simply draw this now and try and locate that point and do it by trial and improvement, or trial and error, I should say, but this is a different approach. So we've looked now at two different skills. We've looked at performing a rotation, and we've looked at naming a transformation, which in this case was a rotation.